Hello and welcome to Limawi. Today, it will be a weird day because we will do the first attempt at deploying HashiCorp Vault in Podman with Ansible. And as I started that this morning, I'm pretty sure it will not work. Of course, first time. So, without further ado, let's go to the code. So, what I had to do 5 minutes before the beginning of the stream, I had to rebuild my dev environment. So it's still rebuilding. I think it will take roughly 10 minutes, something like that, to be completely rebuilt. And afterwards, we will deploy again HashiCorp Vault in Podman with Ansible. But it means a lot of prerequisites. As you can see, the converge file starts to be a bit more complex than before, because we will first enhance the security of Linux, of Ubuntu. And it's far from finished, but it's already a good level of security. Then we create our networks, a network between the nodes with WireGuard. Then we will install Podman. Then we will install bind9 in Podman in Ansible. That was the subject of the previous stream. Why do we want to install that? To have a DNS, an internal DNS that can resolve everything we will feed it inside the WireGuard cluster. Once we have these bind9 ready, then we will install Vault twice. First time as a transit and the second time as the service itself. What does it mean? Vault uses a seal system. So that means that when you have your cluster of nodes for Vault, all started and all converging together, you cannot still access the secrets. You need to open the seal. And to open the seal, you need a third-party intermediary, a trusted third party, that can give the OK to open the seal. When you are full on-prem, like it's the case here, because with the cloud, you can use the cloud itself as a third party, with the Azure, SMS, HMS, and so on. When you are on-prem, you have two choices with Vault. One of them is to use another Vault as the trusted third party. That's called the transit. And the other is to use a secret share of Shamir. So, in our case, we will use both. Why? Because the transit itself provides a way to automatically unseal without human intervention. So that's good when you want to update your Vault. It will be automatically updated automatically unsealed after the update without intervention. The problem is that for that you need a third party anyway, because unseal the transits require the third party, another Vault. So we need to build another Vault as the third party. But how will we open the seal of the third party? That's where the secret of Shamir comes into the play. But the problem is that the secret of Shamir is a manual intervention. So that means every time we will update the Vault, every time we have to unseal it, we'll have to come, us human, to the Vault to open it. So that's not really convenient when you start to have a complex infrastructure with a lot of vaults, a lot of tenants, and that everything is automated, and as well as the updates. And when the updates are automated and that you have, for instance, 10 updates a day, you can't intervene manually on all of these vaults. So that's why I implement these two systems, this system of transit vault and a secret share of Shamir vault. The secret share of Shamir vault, which is in our case called the service transit because it's the one that contains the transit mechanism for the other. So the secret share of Shamir vault will be outside the infrastructure. It will not be updated as much as the other. But as it is outside of the infrastructure, we can restrict as much as possible the access, the attack surface. So it's less critical if it's not as regularly updated as the other. The other will be inside the infrastructure. So it needs to be regularly updated, particularly because it's the risk point of the infrastructure. It's the vault. It contains all the secrets. It's the risk point of the infrastructure. But as it is automatically updated, we need an unseal that is also automated. So that's why this one will be the only element of the infrastructure that can access the transit vault to ask the transit vault if it can be unsealed. And the transit vault will say yes, so you have your automatic unseal. So you have the transit vault outside the infrastructure that will be open, unsealed by the secret share of Shamir. And inside the infrastructure, you have this vault that will use the transit system to ping the transit vault to automatically unseal. So at the end, you need two vaults, but you reduce a lot the human intervention. Okay. So that's why we have these two playbooks there. And we will open 6 virtual machines today instead of 3 because we will need 3 for one vault and 3 for the other. So once that's clear, we'll talk about something else. The nodes. I want the nodes in Vault to be TLS from the very beginning. The problem is that Vault itself is supposed to handle the TLS mechanism, the certificate mechanism, the certificate authority mechanism. But it's not there yet because we deploy it. So the TLS certs that are used by Vault itself at the beginning can't be provided by Vault itself because Vault itself is not there yet. So we need to create a pair of TLS keys and certs that will be used for the first iteration of our Vault. And once Vault is up, it will take place and replace them with the ones that it will create automatically. So to do that, we will talk about certificate authority, chain of trust, and intermediate certificates. The idea is that as the same principle as the transit vault, we want our CA to be offline to reduce as much as possible the attack surface. We want our CA offline. But as it is offline, it can't be used in intermediate system because it needs manual intervention every time. So, in order to have a CA available in the automated infrastructure, we need an intermediary one. So the idea is with the offline one, we will sign an intermediary one. This intermediary will be used as the CA inside the infrastructure, and it will sign all the other sets. And if this intermediary is corrupted, then we can revoke it through the offline one. So we have the best of both worlds. So in our test, we will do that. We will create the offline one, which will be online just for the test. And with this one, we will create an intermediary one. And we will install this intermediary one in the Podman definition of Vault. And we will go a step further. We will create an init task, init container that will automatically create the cert from the intermediary one to be used by Vault. Good. So, I want to create these certs. To be able to create them correctly, I will need a custom directory here called Vault. Or container that will contain keys and cert, and that will be mounted as a shared volume between the init container, the Vault container, and the Vault agent container. The init container will be there to create the first TLS certs. The Vault is the service itself, and the Vault agent will be there to regenerate these certs, to do the rotation of them. Don't try to help me, please. Up. VS Code. Okay, container. So I need to change the mount points for them in the listener and in the transit app. Okay. I think that's the it's also there in of course the raft pinging. Okay, and now the stateful set. Which is etc SSL vault, etc SSL container, sorry. TLS. And it's declared here. And here. And it will be used here. Perfect. But also in the container. And I need to see if there is a lease to claim the volume only once, or if it can be shared. TLS etc SSL container. And now podman cube play, and I want to see if we can share containers, I mean volumes between containers. It seems okay. Yeah, it seems possible. Perfect. Okay. That's for the internals, and now we need the externals. So we need the pre-step to create these certs. So I will just create a cert. Do we want to test? No, I will just create a CA, and that will be enough. Create C key, create certificate. Okay, I will just take that, put that into this. Create CA key. CA cert and CSRT in CRT format, X509 format. Okay. I want to put them in a SSL directory. Okay. Also need the config file. Okay, it's not cube1, it will be CA, simple CA1. The ca.cnf, I will put it in the Vault Ubuntu test directory. But I need to see from where do I call. I will do an absolute path because we are in a well-known virtual machine. Vault Ubuntu. Copy. Past. Sorry, it's in French. Example. Yeah. Perfect. So normally we have our CA now ready. I will just check, sorry, how much place. Yes, I have a bit of place because I will create 6 virtual machines on my computer. So I don't know how much place it will take. I need to upload these CA in the init container. And I'd like to do it the proper way. So that means with secrets. But I would like to mount it. Volume, import, or deployments. Okay, perfect. I want to mount it as a volume. So to do that, I will create 2 variables. Okay, which are basically the CA key and the CSRT path. We are in the role, so I will let it empty, and I will put a short explanation. CA key for the Vault certificate authority. Okay, and CSRT for it. Okay. So I will put these. I will use the same for both vaults because these are root and not intermediary, just for the sake of test. I will for simplicity of test, I will use the same in both. In a prod environment, there should be intermediaries. So that means that, for instance, we can have different CA depending on the vault. And I advise to create. Do I advise it? Yes, I advise it. But that means manual operation each time. So maybe we can do a third level CA. Or a whole process. Okay. So they are in the directory. Here. Up. Key. Okay, so they will be caught up. They will be caught up. They will be caught up by Ansible. But now I need them to be caught up by Podman. So in order to do that, I need to create secrets. Up. I have a secret definition here. And to it, I will add how will I do that? I will write the name here. What's the name? Vault CA, simply. Let me think. Actually, I need two secret directories because the Vault CA1 will be read-only. It's the principle of secrets. They are mounted read-only. But the problem is that I want to create other certs with them, so I can't put them in the same directory because this directory is read-only. So what I can let's create a etc secrets directory. Yeah, why not? No. In terms of, I try to be as much semantic as possible, and let me think. If I create a CA directory, yeah, that makes sense. Okay. Okay. Then we can mount these directory for the secrets. Perfect. So we want our vault CR30 and our vault ca.key, and we want the same thing for client ca.crt, right? The transit, it will come later, but let's start with that. Oh no, I use the same Vault CA. Oh. Okay, yeah, I need the client one. Vault client c.crt. Vault client ca.key. Okay, I have them all. Then I will need to put them here. Oh, client ca client and client. Okay. We use the same. Even if we can use another one in prod. Okay. I will just check one thing. Yes, we ping to the correct IP. Okay, so we ping to inside the WireGuard network. Good. I want to look up and indent, not the template, but it's a file. The file, simply the file. Vault ca.crt path. Okay. The indentation is all wrong. Okay. Okay. So we have our secrets. Now we want to mount them. And for that we need to declare first as volume. Secret plural or singular? Never know. I will consider singular. The kind is singular. Secret. Secret. Okay. So the volume is declared and we want to use it only in these Copent Vault OpenSSL, so this init container, because we could use it right away after the start of the cluster to upload the CA and its K to the cluster itself. That makes me think we need not an OpenSSL but a Vault agent here. Init. Okay. So I will have to fetch the official Vault agent one. So secret, and that goes into CA. Okay, now we are set. Now I have to fetch. Can I use the Vault image? Does it contain the agent as well or not? I would consider that it contains the agent as well, right? What's the Vault CSI provider? Vault Kubernetes, okay. Vault Enterprise, okay. Vault Enterprise FIPS, okay. Vault Secrets Operator, okay. And simply Vault. So let's consider that the agent is inside. The CSI secret store driver. Oh. Mm-hmm. Okay. I think then we need only the Vault image. And if we override the command, perfect. Okay. So we have our CA that is mounted as a secret in the init container. The init container itself will create the TLS cert and keys, and later, once we have tested that, later it will create the the CA itself. I just see that I need also to move the CA themselves in the container directory. Otherwise, we won't be able to start the Podman services because they will lack the CA file inside. So we just need to do that. Okay. And now we have our CA in the command volume between the init point and the container itself. So the container itself will have the CA with it. Good. I will add some lights. And drink some water. All right. So let's start. Do I blow up my computer? We'll see that right now. First, we create the artifact. And then I blow up my computer. Until now, everything's good. Jusqu'ici, tout va bien. But you only have one machine and it's not yet completely up. We expect 7 machines. Just to check how many CPUs did I give them? Only one. Okay. And the CPU, I have normally 24 logical CPU. Okay. Okay, so that should be okay then. I'm thinking to have all the satellites together, then I need only 6 VM for all the satellites. And 3 of them will not be very used because they are there just for the transit vault. Then, once the satellites are in place, for the kube cluster itself, I will need 2 nodes for the masters because the etcd cluster will be in the satellites, so we don't need 3 nodes for the masters, only 2, one to heal the other, and 2 or 3 nodes for the workers. So that means 8, 10 or 11 VM plus the provisioner, so 11 to 12 VM. 1 CPU each. So that means 12 CPUs, half the capacity of my machines if I have only one machine, so half the capacity of my machine if the virt manager displays the proper number. Why multiple machines? Because later the idea is that the virt manager will be exported in a cluster, a physical cluster, and I will spin up my VMs from these physical cluster. But today we'll do with only one machine. So, second VM to up. Hello, Niliam. I'm fine. And you? How are you? Fine, too. Perfect. I tried to blow up my computer. No, I have to do a test with 6 virtual machines, and I'm not sure my computer will be able to handle that. So we'll see. So just as a refresher for you, Niliam, I try to deploy 2 Vault clusters, 2 HashiCorp Vault clusters with Ansible and Podman, because I need them as satellites to a good Kubernetes cluster. Why using virtual machine and container? Because my goal is to deploy a kube cluster, and a kube cluster can be deployed only in virtual machines. So I need virtual machines to be able to test the deployment of the kube cluster. And as I'm doing the satellites around, I need also virtual machines to handle the satellites around the kube cluster. By satellites, I mean all the services that are needed by the kube cluster to work properly even before it is started. For instance, network, I use WireGuard for that. For instance, DNS, I use By9 for that. And for instance, Vault, because I need to store secrets and I need to create certificates before even the startup of the kube cluster. And the etcd cluster, of course, and the BGP nodes to be able to route the interfaces of the cluster to the outside world. So I use virtual machine for that because the kube cluster needs virtual machines. And once the kube cluster is up, then it will be only containers. And by the way, inside these VMs, I use Podman and I declare these services as containers with Podman. An example here, it's a Podman Kube Play. This one is to deploy the Vault cluster. Vault is there to handle all the secrets? Yes, that's the idea. Vault, the first goal of Vault here will be to be able to create certificates and rotate them, because we need certificates to ensure the security and the encryption of the communications between the kubelet services and the kube cluster. So we need Vault before the kube cluster because we need it to be able to create good certificates and to rotate them properly before we start to deploy the kube cluster. That's the first use case of Vault, and afterwards there are many use cases with passwords, tokens, and everything. So, fourth node. Okay. And currently it seems to work. Seems. I open a top on another screen to follow the performances of my computer. Just to be sure, but it seems to be okay. The process that swallows the most is OBS, of course. OBS and Ruby, because Vagrant is developed in Ruby and we have Vagrant currently running. Fifth VM. Takes a bit of time, but 6 VM on one host, it's normal. Please start. Please start. Do not fail. Yeah, perfect. And now the 6th VM, and then we have the provisioner, and normally it should be enough. Okay. Bit slow. And now the provisioner. The load average is still good. The provisioner is another image, so it needs more time to be spun up. Are you using Vagrant or you boot the VMs directly by using Ansible? I use Vagrant. Vagrant plus libvirt to boot the machines. Because I don't see any use case in using Ansible to boot machines now, because the next step will be to boot machines through kubevirt. The day I start developing the operator to do kube in kube, I will use kubevirt to spin up the machines. So Vagrant is cool for testing, because you can describe the network between the VMs. That's cool. Yeah, currently I don't see any use case for Ansible to spin up the machines by itself. Maybe later, if Vagrant starts to be obsolete, because Vagrant is not in a great shape currently, If Vagrant starts to be completely obsolete, maybe I will switch to pure Ansible. Or pure Cube. I mean, if I have Cube infrastructure completely running, maybe I will evacuate Vagrant slowly. Container effect. What do you mean, container effect? The fact that Vagrant is, yes, container effect. Certainly, yes. I think Vagrant was at its peak in 2000 and I will say 2015, 16, and now it's slowly decreasing because people rush to containers, forgetting that before containers we need machines. And yeah, for dev tools, I don't see any alternative except Ansible, as you said, except doing everything through Ansible, but another iteration later. So the provisioner is there, all the machines are there, my computer is still there. Yeah, looking good. Okay, let's start the deployment. So the deployment will certainly break before the end because it's the first time I deploy the combination of Vault plus a transit Vault. So it will certainly break before the end. So first step is consolidating the OS, Ubuntu in our case, which is the most widely used Linux operating system. So that's why I test on Ubuntu. We are midway in the security because there are still some stuff to do. And we have a process to check that called Linux. And I sent a tweet yesterday, I think, because there is something missing in Linux for me. It's the fact that we can't export the test results in JUnit format. We can only export them in a custom format based on ANSI and BAT files, but it's... let's say that I would like to have them in JUnit to be able to import them in the same flow as the other tests to create a correct test overview, test dashboard, and documentation. Manipulate them and yeah, render everything properly. So currently I tweak it a bit because I run my test with Ansible as well. So I tweaked it a bit to appear in the results because I just check for warning and suggestions. As there are some warning and suggestions still, and I will handle them later, I commented that. But the idea is that normally test results should appear there. So at the end of the day, as I export my test in JUnit, maybe certainly the Linux tests are exported as well. But it's not, I mean, it's a bit dirty. So, slowly we increase the security of our machines. As you can see, every time we do something, it swallows all the resources of the machines. And that's perfectly normal because each machine has only one CPU and 1 GB of memory. So these are very, very small machines, but that's on purpose because I want to test my system with the least resources possible. Fourth machine. Fifth machine. Sixth machine. And there is a whole project on the VM security, Linux security, that I will handle in 2024, I think. First thing first is the kube cluster. We have a decent enough level of security already for our Linux stuff, but I will still improve that. So now we are building the WireGuard mesh, so all the machines will communicate together as if they were in the same network, because they will be in the same network, same private network, handled by WireGuard. All 6 of them will be able to ping all the 6 others. That's great. All the 5 others, or the 5 others, sorry. In mine 9, what's happening? Failed to find required. I forgot. What? No host matched. What did I do? There is a subtlety that I removed, and now it's broken. Satellites nodes. Yes, they are all there. So is it a typo? What is wrong here? No, the satellites node are described. Vault nodes. Satellites nodes. I mean, they are described, they are there. What's happening? I don't really understand what's happening, because the satellite nodes are described. No host matched. Did I do a typo? It's possible that I did a typo. I know. I think I removed. Let me check that. Let's check the bind 9.1. I think I removed the. No, I didn't remove them. But anyway, I think they should be there. The 2 dots. Let's check. Yeah, I think that's the problem. Why does it appear now and not before? That's a good question. But Let's correct that. If it's the problem, I'm not sure. And to debug that more properly, we will use our dev environment. So first, let's sync all of that in the dev environment. Okay. Then let's go into the provisioning VM. Okay, and let's go into the deployment directory and let's redeploy all that. So it's not bind 9 anymore, it's Vault. Okay. Sorry, it's not Vault, it's the whole process that finishes with Vault. By the way, that's something I have to change in Vault itself. Yes, here it's not DNS, it's Vault. Okay. And we will use the converge instead of the service. So we'll redo the whole process. I really want to see what's wrong. Where is Podman? Here. Okay. Satellites nodes, they are there. I don't know what happened. So when we will add more nodes, slowly, step by step, we'll start parallelizing more. Because Ansible is supposed to be a scheduled process, so it's supposed to run always. So we need it to be more efficient. Regarde. Okay. Regarde is there. And now Podman, please. Podman works. Ah no, yes, sorry. Converge, regarde. Okay. Boom, boom, boom. Podman. Podman works. Okay. I don't know what happened before. These 2 dots, maybe. Perfect. So we are installing Podman on the satellites nodes. As written here, satellites nodes. And once Podman is installed, we install by9. And once by9 is installed, with normally by9 should be able to detect vault.undercloud.copen.test and transit vault.undercloud.copen.test. undercloud.copen.test. We'll start Podman. We install by9. Please by9 works and detect the correct ones. Please, pretty please. And after by9, of course, it should fail because Vault is not finished yet. That's true, I didn't test. Yeah, manifest. As you can see, Vault fails. Sorry, my nose is itching. First thing I want to test is if by9 correctly detects the additional references I put. And I forgot to do one test actually for by9. I forgot to test if by9 can recognize itself. So ns lookup, the port is what's the port? Took the default one, so it's here. $50,053. And I want to test DNS dot in a cloud dot test on by9 is installed on the first and second node on the internal IP of them, the WireGuard IP. So what can you provide? Yes, detects them correctly. Okay, that means I should also write the test, the corresponding test. Test DNS DN lookup. Same port, but we test. Okay, I will soft code it. Up. Up. So I want to test this one, and it should result. Let's. I want to test this one, and it should result in the following IPs. So that way I have my test structure, and I will test. Yes. Okay. Okay. 1 and 2. Hello. And 2. Okay. So I have my small test structure to test if the definitions are correctly viewed by 9. So I want to loop. I want to do a double loop. I should hash map that. That will wait for later. I will prepare that for next time. Up. Ansible nested loop. Okay. A loop can combine nested lists. Yeah, that's what I want. Perfect. I want the list of servers and the list of DNS. Even if, is it, yes, it's a correct list, even if the list itself is a dict. So I loop into the group DNS nodes. Okay. That will be my item 0. Okay. And I want to loop into the DNS variable product list. Okay. Okay. And then here I need my item 1 dot name. Yes. And I want to ensure that it fails when test DNS declared dn lookup. And I want to ensure that it fails if DNS declared How do we iterate in item? Oh, yes, I see. Failed, check if DNS resolves up when DNS declared lookup results and I want to see if no, those far I don't care anymore. These two ones I don't care. I care only about the two last one. Okay. So the last one I want name is item 1 name. Okay. And the address is item 1 IPs, and I should iterate over them. Name, address, name. Okay. Address, item, IPs not in item std outlines. Do I do another loop? A loop in the loop in the loop? Or maybe I flatten my test. Considering, yes, I should flatten my test here. Considering that we should test for every case, we should have up, up, there. We repeat the name again. And the IP. Okay. There. So I don't know if this test works. That's not the question here. Just to be sure that for next time we test that. But now I want to be sure that volt is not detected. Okay. So that means that variables are not overridden between the cores. As I was afraid of that. Import playbook with custom variable. Vars, okay. I want the var file, please. Import playbook. Let's test that. So first I will put the FQDN because I want to have the FQDN. And I will do it the correct way, the complete way. So with the name, because it's important for the documentation. So instead of silly import playbook, I will do name, enhance Linux security, because this one is about that. And I will put var file we declare them here. Let's hope it works. This one is about the WireGuard mesh. Create WireGuard mesh. Okay. We will also give it the var file. I have no idea if it works what I'm currently doing, but let's hope. Podman, install Podman. Okay. Start bind 9 service. Okay. And up, up. start vault with SSS service, secret share of Shamir. Start vault with the other vault as back as unsealer. Yeah. Okay. Then we give to all of them the var file, except the two last ones. And let's hope that works. I have no idea. I don't know if my syntax is correct or not. Let's check. No, it's not. Var file is not a valid attribute for a playbook include. Okay. Ansible. Import playbook with custom var file. At the end of the day, if it doesn't work, I will write the vars directly. Ah, I'm not the only one with this problem. Okay, so I will call just vars and override. override the ones we need. But that means that I need to understand that I need proper variables that are really tailored to one playbook. Okay. Okay. Linux, what is his var file folder? Okay. Podman. Okay. So by9, you are the one with many elements. Ah. Okay, so that means that first good thing, we don't need that anymore. That's the good thing. Because they are encapsulated here, and the playbook, when we call it, it will use this file anyway. So we don't need to call them again every time. So that also means that I can factorize that here. Yeah. Okay, perfect. And then we can exclude them. Okay, perfect. Okay. It's cleaner. So what we need now to do is to override. So what I will do is that. Okay, and the Waga network. Okay, and we need up. This override there. And we will override our call here with just the var. Up. Okay. Like that, and that's a variable. There, that's better. Okay. So we have stronger separation between interfaces, between the playbooks in our case, because the interfaces are defined by the playbooks. So it's cleaner because we see here the only interactions that we have between them. Otherwise, they are fairly independent. I'm thinking about something. There are some variables that are repeated between the calls. The Podman ones, I think I use them every time there is a Podman. So, in order to have a proper stuff, we need to overwrite them every time, but that's good because we really declare our variables correctly. Let's go to converge. Converge, we will do the same thing as here. Pum pum pum. Regarde, mesh, binary. Here. Up. Service. Okay, we don't override here, but we will override podman here. Okay. With the podman related stuff. So we strongly declare our interfaces because we declare the variables that are that leak between the modules. And okay, network. Okay. That's cool. That's really cool. And actually, I prefer that to the var file because with the var file, we lose a bit the focus because you can put a lot of shit in the var file, and that's contrary to the software craftsmanship and the hexagonal architecture because we need to have the less possible elements that leak between the interfaces. So that's cool that you have to declare them because that's where we have a tendency to restrict them. Okay, here, pop, 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 pop. Up. Okay. WarGuard needs just that. And there is no leak between the interfaces at the WarGuard level yet, but maybe there will be one because WarGuard we maybe need to handle the DNS as well. Not completely sure. I think we can do without it, but can do otherwise, but that needs to be seen. And let's go back to Vault. So in Vault, we need to also override podman. With the same trick, which is that. Actually, shit. Yes. It will not work because the var file is not called. Include var. I need to put an include var before, maybe. We'll see. But anyway, the syntax is roughly that. I think I need to include the vars before to be able to use them here. But we are normally good. So that's it for today. You see it's winter time, less and less sun. You see more and more the green screen behind me. I think I will have to put the lights again, the heavy ones. So for YouTube and others, I say to you ciao and see you next week.